Hey there, this is Jake from Pigeon Forge. Thanks for joining me. Today I'm going to talk to you about Java hash maps. Hash maps are a very cryptic and somewhat scary topic in Java for many new programmers. But once you've played around with them a little bit and understand their purpose and how they work behind the scenes, I think that you'll have a much better appreciation for them and you'll be able to use them day to day. There are probably very few examples of programs where you can't use hash maps. I think they're a very powerful tool and should be part of every programmer's toolkit. Okay, so what is a hash map? A hash map is basically a dictionary. If you're familiar with Python, it's really a good analog to Python's dictionary data type. By dictionary, I'm talking, and if you don't have experience with Python, by dictionary, I'm talking about having key value pairs. Something equals something else. The key is such as it's like a word in a dictionary, and the value is something like the definition. A dictionary, all of those keys are going to be unique. You may have multiple definitions for one word, but you're going to have the one word listed and then those multiple definitions listed as the values all put together in one lengthy definition. So again, a hash map is basically a set of key value pairs. It's basically a dictionary. What exactly is hashing and why do they call it a hash map? Hashing is when you take a key and you run it through a hashing algorithm to create a hash. And that hash is actually what you use to perform the lookup. It's very popular and common with passwords. Passwords are not stored as plain text. They're often stored encrypted in hash tables. In this case of Java, we're not really doing it for encryption purposes. We're doing it for fast lookup purposes. Now, with hash maps in Java, they're not restricted to just string equals string. The key can actually be of any data type, any class object. It can be a string, can be an integer, it can be an object, whatever. The value can also be of any data type. It can also be a string or an integer or an object. However, all of the keys must be of the same type and all of the values must be of the same type. The key and value can be different, but all the keys have to be the same and all the values have to be of the same type. So why would we use a hash map instead of just arrays or regular class objects? Although you could create arrays, say two arrays of the same length to accomplish a very similar outcome, you then have to deal with two separate arrays. For example, you could create an array of names and then an array of ages, and they're of the same length, say 5, and index 0 of array 1 equals index 0 of array 2. So you could look up the index 0, which is, say, my name, Jake, and then get my age, which is in the other column. Let's say it's 27. That sounds like a good age, but that's a pain in the butt because you now got two separate arrays that you're constantly working with, and it's inefficient. Say you want to look up my name, you want to look Jake up in the array. You actually have to search through the entire array to find my name. Whereas with a hash table, that hash goes straight to that value, and then it pulls up the whatever is stored as the value for it. And then with objects, when you create an object instance, that instance name is just a reference to where that object is stored in memory. But how do you dynamically reference all of those objects? If you've got 5 million records, or if you've got 5 million instances of objects, say you're trying to represent people, how do you dynamically reference the variable that you've named each of those? It's very difficult. Ideally, you would store those in some sort of array, or maybe better, in some sort of hash map. Okay, say we want to create a database of pets. We're going to use something to uniquely identify each pet. And let's pretend that each pet has a unique name, that no two names can be alike. That would be a great use for a hash map. However, some people may try to actually build instead a bunch of objects of the type pet. Now that's good. You create a pet class and you create these objects. However, how do you easily access those? If all you have is a group or say an array of objects, you would have to do a for loop through that array, one by one, pulling up each object in the array and checking its name to find out which one is your target name, and then you can access the rest of the attributes of the object. It's better to have that unique identifier, that unique key, stored somewhere else as a reference, such as a hash map, to be able to access that object. So ideally, you could probably still put name in the pet's object instance, but you would use that name or whatever the unique identifier is separately as a lookup. And that's what you use a hash map for, so you could quickly look up that unique identifier. And it's worth noting, this is actually how most databases work. Most databases have a table is going to have what they call a primary key. And that primary key is something that is unique that to each row of data. So let's say it's a table of people, and the unique identifier is going to be social security number. That's something that's unique that no two people have. That would be the primary key. And so if you wanted to look up that object, you know that if you pull on a certain social security number, you're only going to get that one object. Now, there are ways to access the other data as well. If you want to, sort everybody by their names or by their location or whatever. But there's the one unique identifier, the primary key, which happens to be the social security number. So that's an easier way to access the data. Okay, so let's do some practical exercises. We're going to bring up Eclipse, and we're going to create some arrays. We're going to play around with those arrays, and I'm going to show you how cumbersome that is and how complicated it is based on what I just said. We're going to loop through them, and we're actually going to convert them into a hash map. I'll then show you how it's easier to access the data and manipulate the data by using a hash map as opposed to multiple arrays. Then we'll create a simple class, and we'll play around with that class a little bit using hash maps to see how quickly we can build a complex data set and access it. Let's head over to Eclipse. Okay, so here we are in Eclipse. Let's go ahead and I do have a sample project area created so that I know what the heck I'm talking about. But let's go ahead and create a new class here, and let's call it Hashmaps tutorial. Call it Hashmaps tutorial as the package, and the name will be Hashmaps tutorial. And we want the public static void main, and I think that looks good. We hit finish. Okay, so now we have Hashmaps tutorial, and I hope that this is large enough for you to see, but I'll make it a little bit bigger just in case. And let's clear this out of the way and make it even a little bit bigger. Hopefully you've got a little bit of experience with Java. If you don't, I would recommend that you maybe go back and see some simpler tutorials that are going to cover some of this, because you may be quickly overwhelmed. Java is not necessarily the most intuitive language for beginners. If you've got JavaScript experience, you'll be fine. Okay, so first, let's go ahead and let's clear this out here. Create two arrays, one of names and other of ages. This is what we're going to do. Okay, so let's create the one of names. String, it's going to be an array, names equal Luca, Jake, Ahmed, Layla, and Kim. Okay, so we now have an array of names. Let's create an array of ages. These ages will be, let's do int. Now with this, we could probably get away with smaller number sizes, number data type, such as a short or a byte, but maybe we'll have angels or demons included, and those can get kind of big. So let's do 52, 27, 30, 25, 20, and close that. Okay, so now we have two arrays. Now how do we link these arrays? Like how can we say that Luca is 52 and Jake is 27 and so on? Well, we could just try to keep these all in order and know that the zero index of names is the zero index of ages. So Luca's 52 and so on. That's a bit of a pain. So let's see. Let's print Luca's age. Think about this for a second. How would you access Luca's age out of these two strings? Well, the only way to really do it is to use a for loop. For int I equals 0, I is less than names.length, I plus plus. Okay, so that create a for loop. And then if we say if names I, so it's a string, so we say equals Luca, and then we do another block here. And we say system.out.println, and we say ages I. This, if you know anything about data structures and algorithms, you'll know this is a horribly inefficient way of accessing the data. But let's go ahead and run this. Let's see what happens if we run this. We got to save all, okay. And we get 52. Wow, that was a really complex way of storing ages. So then if we wanted to actually make some adjustments, we're going to have to do manipulations on two different arrays, and that will very quickly get very complex. So there is a So that's one way of getting Luca's age. There's another way of getting Luca's age, which is a less hard way, but requires a Java module. And you can do system.out.println, and you say java.util.arrays.aslist names, and then you can do index of, I don't know why that's there, index of Luca, and this is where it's a real pain in the butt. So that gives us the index of where Luca is, but now we have to get his age. So we say ages, and then in, why did that not work? There we go. And now let's try it. And we gotta save it. It's a little better than the for loop, but I'm sure that it's just as inefficient. So that shows you why arrays have some serious limitations. All right. Now, let's convert. Let's actually, we'll just go ahead and comment that out. Sorry about that. I don't want to get rid of it. I just want to comment it out. All right. Let's go ahead and do a section on hash maps here. Okay. Instantiate new hash map. So for the hash map, you said in order to build one, just like just like other objects, you start with the name of the class, but here you're going to actually use the angle brackets, and you're going to have the two data types, so string and it's an age, so we'll say integer. Now we don't use int here; we actually have to use the class name, and int is a primitive reference, whereas integer is the actual class name. And then we use the name of it. We'll call it age map equals new hash map, and then we just do angles, and then we have to do the parentheses, and then we close it with a semicolon. Now you're going to see that HashMap gives us an error, and it's because we haven't imported that module for HashMap from Java Util. So one nice thing about Eclipse, if you don't use Eclipse, is you can just click on import here, and it goes ahead, and if we go up to the top, it imports it for us, import java util.hashmap. So now we have that imported, and those errors go away. Let's go ahead and build, let's see, merge our arrays into the map. This actually isn't too bad, so we'll do a for loop for int I equals 0, I is less than, say, names.length, and then I++. All right, and we say age map, which is the name of our map, dot put. Put is how you add an item to the map. Say names I, and then we say ages I. Okay, and then let's go ahead and print out the map. System.out.println. We say age map, and that should print it out. Let's try it out. Let's hit Control S, print. All right, so let's go up here and let's get rid of, let's go ahead and comment this out so we don't get that again. Okay, so now you see our, the result of our work. We have a map, and this is what it looks like. J equals 27, Luca 52, and so on. We now have a map of ages and names. Now, let's perform the same operation that we did on the arrays, and that is to get Luca's age. So how do we get Luca's age for a map? We do that by, we say age map, which is the name of our map, get Luca. Okay, and that will actually get it, but we need to print it out so you can see it. System.out.print. Oh shoot, I lost my age map. Sorry. Age map.get Luca, and let's put here get Luca's age, and we're going to go ahead and run it. Let's always save resources. All right, so now we get Luca's age is 52. This is the line of code in order to get and print Luca for a hash map. Let's go back. This is the line of code to get it out of two arrays, or you use this for loop here to do the same. So as you can see, we have about half of the code necessary, maybe even less, maybe a third of the code necessary to get that out. So that is how you get out the value for a specific key. Now, there are plenty of other functions that we can perform with Java hash maps. We can, let's see, check to see if a key exists. We would do age map dot contains key, and we would do, let's say, Layla. All right. And let's do age map dot contains key Frank. Now we know that Layla's in there, but is Frank in there? I don't think we put Frank in there. We're gonna have to, let's do system dot out dot print line. Go ahead and copy that so I don't have to copy it again. Age, okay. And then we'll put it here too. This will actually return, it's going to return a Boolean value. So let's go ahead and run it now. Okay, so true, Layla is contained in the age map, but Frank is not. That's false. So that's helpful. You can use that for certain things if you need to check to make sure that the either that it does or does not exist before performing other operations. Okay, let's now check for a value. Check if map contains a value. And for this we would do, let's go system.out.print line age map dot contains value. Let's say 27. Okay, and we are going to run it. True, it does, but let's change it to 25. Do we have somebody who's 25? Oh, we do. All right, so let's try 21. And false. No, we don't have anybody whose age is 21. This specific one, this contains value, is actually really helpful when you start using objects as your values. All right, next, let's try to let's add a value. We've already done this, but let's do it again. So age map dot put, and you see how it fills in for us. It goes ahead and creates these two values, the key value pair, so null and null. So the first one is going to be, and it tells us it's a string that we have to use because it's referring back to that that map we already created. So let's use Lucifer, and we're going to say that, say that his age is 5,000, and this is why we did not use a shorter length for our number value. So age.put Lucifer, okay, and if we run it, nothing really happens, but he's in there. So let's go ahead and print out system.out.println, and we're going to print age map. Okay, let's go ahead and run it again. And now we see that Lucifer's in there, Jake's in there, Luca's in there, Layla's in there, Ahmed, so on. Now, these maps are not sorted. They're not sorted values, so you can't always rely on the order in which they're going to come out. It is what makes them faster, is they're not sorted. Okay, let's now, one thing about put that you need to be aware of is put, if the item actually exists, put will change the value if you have a different value. So let's say Lucifer, he's not really 5,000, he's 10,000 years old. Sorry, my wife and I have been watching Lucifer on TV. Okay, and then let's just go ahead and copy this again here. Why did that not? There we go. Okay, and run it. Okay, so the first time he's 5,000, the second time he's 10,000. So put will, if the object doesn't exist, or if the key does not exist in the map, it will add it with that value. If it does exist, it will change the value to the one that you've specified. That's what put does. If you don't want to actually change the value if it already exists, then you can use what is called put if absent. So put if absent. Okay, so put if absent. So we're going to say age map dot put if absent, and we're going to say Lucifer 20,000, and we're going to say age map dot put if absent, and we're going to say John, and he is 20. Okay, and let's go ahead and then grab this real quick and print that out. Okay, so we used put if absent Lucifer 20,000. Now Lucifer was already in there, so it did not change the value. You see 10,000 here, 10,000 here. However, John didn't exist in the second one, and so it went ahead and put John in there as the key with the value of 20. So that's how you do put if absent. Now what if we want to replace a value? You can use put, but replace also works. So let's replace a value. Say age map dot replace, and we're going to say John, and he's actually 45. Okay, and then we're going to say system.out.print age map. All right, so John we changed from 20 to 45. Now what else can we do? Let's now let's remove a key value pair. So we say remove a key value pair. We say age map dot remove. We don't like having Lucifer in there. That's a little too devilish for us. And then we're going to print it out again. So now you see that we've removed Lucifer from the map. If you've worked with arrays enough, you will see how this is so much easier than working with the arrays. Now, how do we iterate over hash maps? Well, say iterate over keys. There are a few ways. The first one, we are going to iterate over the key set. So we would say for. We would say string name age map key set. And then here, nope, so we need a block. And then we would say system.out.print line name. Okay, so what we're doing here is we're doing a for each statement. If you haven't worked with for each statements, please look into those in case this is a little complex for you. So for, and then we declare a string name. And what's going to do is it's going to return a name for each key in age map. It's going to return a name, which is going to be the key, that's a string, and then it's going to print that name. So let's see what this does. All right, so then we have Jake, Luca, Layla, John, Ahmed, and Kim. So that's how you would iterate over keys. Now you can do some things with this if you want. You can make some changes. You can do who knows what. So let's go ahead and iterate over values, and this is going to have its purposes as well. Let's get the average. Let's get the average age by iterating over the values. So let's go ahead and let's say int sum equals 0, and int length. Sorry, no. Yeah, int length equals 0. Those are just going to be placeholders to store the sum of the ages, and then the length of however many key value pairs are in there, and then we will divide the sum by the length to get the average. Now, you can get the length of the dictionary or of the hash map in another way, but I just want to show you what it looks like to iterate. So let's go ahead and do for int value age map dot values and block. Okay, so sum plus equals value and length plus plus. Okay, so what we're doing here is we are doing a for each statement against the values of the age map. So for each value in the age map, assign it to this temporary placeholder's value, add it to the sum, and then increment length by 1. So it's going to loop through here, and let's see. So then that's going to give us some totals, and then we can go ahead and let's say print average. We can do that by system.out.print line, say average age, and then we say plus, and we could say, now we say sum divided by length. And there we go. That looks good to me. Let's try that out. And then we have average age is 33. Now, we could also cast this to a float if we wanted to get a little more accurate. Try it again. And we actually get 33.166. Now you can actually iterate over both the key and the value if you want at the same time. This is a little more complex, but bear with me here. So iterate over pairs. Let me say for. I'm going to have to say HashMap dot entry, and then we say string integer. Now we're again clarifying what those data types were. Entry for age map dot entry set. Okay, and then we're going to do, let's say we want to just nicely format some message as to what the data is that we're seeing. Say string key equals entry dot get key, and int value equals, no, we say int, yeah, value is fine, we say value equals entry dot get value, system dot out dot print line, and it's going to be key plus is plus value plus years old. And let's print this out. Let's try that and see what that looks like. Okay, so it iterated through the list, through the hash map, and gave us Jake is 27 years old, Luca is 52, and so on. So that gave us all of that pretty much covers most of the basic operations against a hash map. And you can get by on those, but let's go ahead and play around with, I want to do a quick introduction to classes with hash maps, just so that we can cover what I mentioned earlier in the start. Okay, working with classes. Let's go ahead and create a class. I'm not going to get fancy here. I'm just going to create it within the main class. Let's create a class called person. We'll go back to the IRS example, class person. And this person is going to have a name. Sorry. And this person is going to have an age. And we're going to leave, that's going to be fine for now. That's enough. That's enough information. But we know the IRS collects a lot more, but we're going to go with this one thing. So let's go ahead and create a constructor. So public person string name int age, and block, say this dot name equals name, this dot age equals age. Okay, so that creates a person. And what's the error? The error is saying we haven't used it yet. Yep, saying we never used it. But let's go ahead and create some people. Person one equals new person Bob, who's 12. Let's go ahead and just copy him. Let's say person 2 is Frank. He's 22. And then we can go on and we can create several of these. Let's create one more. Person 3, new person Bob, Lucy, and Lucy's 32. All right, and let's create an array of people. Person, brackets for an array, and we're going to call it peeps equals, we'll say person 1, person 2, person 3. All right, so now we have an array of peeps. What can we do with the array of peeps? Well, we want to create some social security numbers. So let's create a string array of SSN array. And that is going to be, oh, this is going to be a pain. I'm going to have to retype this. Okay, so we're going to make this a string. A social security number, something like that, should be a string, not an integer. And we're going to use this. I hope this does not represent anybody's SSN. And I'm going to save myself some time by copying it. Okay, so we have 3 names and 3 social security numbers. These need to be unique, 1 and 2. All right, just as we had worked earlier with the ages and names, to use these 2 arrays as some sort of database would be a real pain. It's not effective, it's not efficient, and you are going to eventually, when you actually get enough data, you're going to hate yourself for building it this way. The better way is to actually create some sort of hash map using, again, a unique key, which in this case is going to be the social security number, and have that actually mapped to the value of a person instance. Let's go ahead and do that. Let's build that hash map. So let's go ahead and declare new hash map. And we are going to say hash map. And the key is going to be the string that represents the social security number. So we're going to say string. The second is actually going to be person. It's going to be of the type person, which is this class that we created up here. And we're going to call this, we're talking about the IRS, so we're going to call this taxpayers. It's a taxpayers database. Equals, and we're going to say new hash map, and then parentheses. It's a little bit funky how you have to do the brackets, the angle brackets here, but that's the way it is. So now we've got this taxpayers hash map. Let's go ahead and add our data to our hash map, add data. And we will do that by iterating through peeps for int I equals 0, I is less than peeps.length I plus plus. And we're going to say taxpayers dot put, and it wants so the first one is going to be it's going to be the SSN array index I, and the next one is going to be peeps index I. And now we should, oops, I mistyped this. And now we should be able to print that out. System.out.print line, and we are going to say taxpayers. Let's see what that gets us. Okay, all the way down here at the bottom. All right, so now it looks a little bit different than the printout that we had for our first hash map. And that's because you see the key, which is zeros for the social security number, equals, and it's actually equals hashmaps tutorial.hashmaps tutorial $person, etc., etc. It equals this long thing. It's because it's referencing an object or an object instance as opposed to referencing just some straight up simple primitive value. So that's what it looks like when we print it out. All right, now what can we do with this? What's the purpose of using HashMap with objects and classes? Let's say that the IRS wants to go after a tax evader. All they know about this tax evader is their social security number, because they've got some algorithm that shows that this social security number has not been paying taxes for so many years. Okay, so the IRS wants to go after a tax evader, and they happen to know the social security number. Let's say it's 000001. That's the bad guy. That's the tax evader. All right, so let's go ahead and get the information about the taxpayer. And we're going to create, in order to get this, in order to be able to manipulate this easily, in my opinion, we're going to create a reference to the object instance that's actually holding this tax evader's information. So if we do person tax evader equals taxpayers dot get, and here we're going to type in 00000001. What this is going to do, just to make sure we get it, let's say system.out.println tax evader dot name. What we're doing is we are digging into the taxpayers dictionary right here. Sorry, the hash map. I keep calling it a dictionary. I'm used to Python. Taxpayers hash map. We're getting the social security number. And what that's doing is it's actually returning a reference to that object in memory. And we're creating this new reference to that object. We're not actually creating a new person. We're creating a reference to the person that's already created with that's listed as this, having the social security number. And then we're going to print out taxevader.name. So let's go ahead and run this. Okay, that's Frank. If we go back up a little bit, sure enough, Frank was person 2 with that social security number. What's cool about this now is now that we have this reference, which is tax evader, we can actually do taxevader.name. Let's change the name. Equals, it's not really Frank. He changed his name. He changed his name to Jill for whatever reason. And let's now do system.out.println taxevader.name. And sure enough, I mean, you probably know what's going to happen. Let's go ahead and do this. But what's really cool is check this out. System.out.println person2.name. Boom. So we actually have, again, we have a reference to the original person2 object. And that's what tax evader represents. Tax evader is not its own new object instance. It is a reference to person2. So now by having this, we can manipulate all of the data in person2. Very cool. Let's get the average ages of the taxpayers just like we did before. How could we do that with this slightly more complex data structure? Let's do it like we did before. So we'll say int age sum equals 0. And we'll say int pop count equals 0. Pop count is going to be the population count. Let's iterate over key value pairs. For person value taxpayers dot values. All we're trying to do is get the ages, right? We're not trying to get we don't need their social security numbers. The social security numbers are really just going to be it's a value that we don't really care about right now. We're only trying to get all of the ages out of this slightly more complex data structure. So we're going to be pulling the values, which are going to be the objects, and those objects are going to be storing the names as attributes. All right, so next we're going to do age sum plus equals value.age, and then pop count increment. And then we can, just like we did before, we could say system.out.print line, say, let's say average age equals plus, and say, let's go ahead and do float again. Now, in the case of just a few variables, we don't probably need float precision, but maybe if you're actually looking at the entire database, you care to have float precision. Say age sum divided by pop count. And let's print this out. That looks good. Average age, 22. So let's look at what's happening here again. So we have a for loop. For that for loop, we're declaring that the value data type is going to be person. Value is the name of the variable of type person. For each of the taxpayers dot value. Now remember, each value is actually a reference to an object instance of the class person. And once we're in the block for each of these, age sums plus value, or sorry, plus the age sum is going to be incremented by value.age. Remember, value now is again a reference to that object, and that object has the attribute of age. And then we're going to increment pop count by 1. And it worked. So I think that's probably enough with Hashmaps for today. This has probably been pretty long. We'll see what it's like when I cut it. It's probably going to be 30, 40 minutes, probably way too long. I hope that this walkthrough has made you a little bit more comfortable with using Hashmaps. You're going to need them if you plan to do a lot of programming in Java. They're very valuable, and they're actually pretty easy to implement once you understand exactly what they are and how they work. Be on the lookout for a future episode in which I hope to do a tutorial on importing files, text files, and using Hashmaps to do some lexical analysis comparing these multiple files. I think that's going to be a little bit fun, and maybe we can make something useful out of it. So thanks again for joining me. I hope to see you again soon. Bye-bye.